Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So, today we are going to learn about boiler troubles. So, coming to overview of today's session, I am going to explain about boiler troubles, in which different types of consequences we have to face if we use hard water in boilers for steam generation. So, among those, priming and foaming, scales and sludges, caustic embrittlement, boiler corrosion. Likewise, so many consequences we have to face. Among those, two are there in our syllabus. One is sludges and scales and the other one is caustic embrittlement. So, let us go through one by one. So, generally for hard water to use in boilers, that means water that is used for steam generation, we have to make use of water that should have hardness, it should be less than 0.2 ppm. If hardness it is less than 0.2 ppm, then only it is able to generate good quality steam. Or else we have to face some kind of consequences, those we will call them as boiler troubles. So, this is the must and should condition for hardness property. It should be always less than 0.2 ppm. So, and the next one, it is alkalinity. Alkalinity, it is divided into two types or two parts. One is caustic alkalinity, other one is soda alkalinity. Caustic alkalinity, it should be in a range of 0.15 to 0.45 ppm. So, that means salts that were present in the water like NaOH and then Na2CO3, sodium carbonate, sodium bicarbonate, NaHCO3. So, likewise, if any basic natured compounds or salts that were present in the water sample in dissolved state, then they are able to release basic natured OH minus ions into the water sample. So, this carbonate ion, if it is present, that means Na2CO3 it is present in dissolved state in water, then it is able to release carbonate ion CO3 minus 2. So, this is able to combine with H plus ions present in the water, thereby converting into bicarbonate ion, that is HCO3 minus. This in return it is able to release OH minus ions which are having basic nature into the water. That means basic natured ions were released into the water due to the presence of salts of sodium like NaOH, Na2CO3, that is sodium carbonate, and then sodium bicarbonate. So, but whatever be the thing, there is a range for alkalinity. If it is like caustic alkalinity, 0.15 to 0.45, and if it is soda alkalinity, 0.45 to 1 ppm. So, this is the permissible limit value. If any hot water which is exceeding all these kind of properties, it is not preferable for using in boilers for steam generation. So, if we use hard water which is having or which is crossing this hardness greater than 0.2 and then alkalinity greater than 1, then what are the consequences, or we can call them as results. So, let us see one by one. So, first one, it is formation of sludges and scales. Formation of sludges and scales. So, what do you mean by sludge? A sludge is defined as loosey and slimy precipitate which is produced due to the presence of magnesium carbonate, magnesium sulfate, magnesium chloride and calcium chloride. Sulfates and carbonates of magnesium and chlorides of magnesium and calcium. If these were present in soluble state in the water, then these are able to convert while boiling in water. If these were present in dissolved state, then they are able to produce a slimy kind of precipitation which is more soluble in hot water. So, that is what we call it as sludge. So, sludge can be defined as a loosey and a slimy precipitate that is purely formed due to presence of calcium and magnesium chlorides, magnesium carbonate and magnesium sulfate. What happens if sludge is present in the boiler water? During steam generation, if we use hard water, it is able to produce sludge, and what happens if sludge formation takes place? So, let us see the disadvantages part. These will act like poor conductors of heat and they reduce the efficiency of the working efficiency of the boiler. Boiler efficiency will be reduced. At the same time, these sludges will act like poor conductors of heat. Sludges, they settle at the bottom or in the regions of poor water, circulation will be reduced, so that choking is the major problem. That means they get arrested during their circulation, water circulation. It is able to get stick to the sides of pipelines, so that the choking of problems may be the major reason. So these are the two disadvantages when sludge formation takes place in the boiler water. How these can be removed? So let us see the removal techniques. So one thing is boiler, in boilers if we use hard water, then sludge formation will take place. Then it can be removed by blow down operation. Blow down operation. So sludges can be removed by blow down operation, which means removal of sludge from the boiler water through an outlet which is fixed at the bottom of the boiler. So after this makeup it is done, we have to allow the passage of fresh batches of water. So that is what we call it as a blow down operation. It's a mechanical operation using which we can remove the sludge particles. So and the next method is, instead of using hard water, as I told you the criteria, what is the criteria for hardness and alkalinity, we have to make use of soft water, or we have to adopt an external treatment before the usage of hard water. Let us go for the next one, that is scales formation. See in this figure, if you notice, these are nothing but kind of precipitates, loosey and slimy precipitates that were present in the boiler water, that is hard water, which is what we got as sludge. If this is not removed, then the consequence will be scale formation. Scales will be produced. They get stick to the inner side walls of the boiler. So let us go with the next one, that is scales formation. Scales are defined as a kind of precipitation or a thin layer, or we can say hard layer, that gets adhered as a coating on the inner side walls of the boiler. If they become very hard and they will convert like a thin layer, that is what we call it as scale. So initially I told that sludge formation will take place in the form of a slimy, or we can say loosey kind of precipitation. So sometimes if it is not removed, it becomes hard, so that it gets adhered as a coating on the inner side walls of the boiler and becomes like a thin layer. That is what we call it as scale. So generally this is due to the presence of dissolved salts of calcium carbonate, calcium sulfate, calcium bicarbonate, magnesium hydroxide. If these were present in dissolved state in the water, then they are able to cause scale formation. Let us see the causes for scale formation. First and most important thing is decomposition of bicarbonates. As I told you, calcium bicarbonates are responsible for causing scale formation. If it is involving in decomposition, that means boiler water means water it is subjected to boiling by supply of temperature. Then due to boiling, this bicarbonate is able to convert into insoluble precipitate of CaCO3. We can notice the precipitate formation. Along with that, water will be released and CO2 gas will be liberated. So if it is for the case of low pressure boilers, this will be the final form, that is calcium carbonate, which is insoluble, so that we can remove that one by adopting filtration technique. If it is for the case of high pressure boilers, so this is not the final product. This CaCO3 again will decompose into calcium oxide, along with that CO2 will be released. This produced calcium oxide again combines with water, thereby producing calcium hydroxide as the final product. So if calcium bicarbonate is present as an impurity in the water sample, that means it is exceeding its permissible limit value, then it is able to cause scales. And second reason, it is hydrolysis of magnesium salts. If any magnesium salts were present, they were subjected to hydrolysis when that water it is used in steam generation for boilers. Then I have taken the example of magnesium chloride, and it is able to combine with water molecules, thereby it is able to convert into insoluble precipitates of magnesium hydroxide. So these are the reasons, or we can say causes for scale formation when we use hard water for steam generation in boilers. So what happens if scale formation takes place? So let us go with the disadvantages part, or what are the consequences. First one is, we know very well, as impurities were present in the water sample, its boiling point will raise. That is, for pure water it is like 100 degrees centigrade. If it is going to increase, that means around 120, like that it is going to increase, then it will reveal that it is having lot of impurities in dissolved state in water. That means wastage of fuel is the ultimate consequence. Fuel wastage will take place, because for getting steam we have to boil the water. If it is not having impurities, easily we will get steam generation. If it is having impurities, we have to supply lot of amount of heat in the form of temperature. So that wastage of fuel will be the first disadvantage. And then it is able to reduce the boiler safety also. boiler safety also gets reduced, because scale is a kind of thin layer of coating, or we can say thin layer that gets sticked onto the inner side walls of the boiler. So as water, it is involving in evaporation. Water, it gets evaporated because boiling we are doing. As a result, it is converting into water vapor. That means steam will be generated. So during this process, the level of water gets reduced. As the level of water gets reduced and the temperature, it is getting increased because of impurities. So we can notice the formation of hairline cracks on the inner side walls. So as a result, there may be a chance for danger of explosion. Suddenly, that boiler material involves in explosion. So it also able to reduce the working efficiency of the boiler. So these are the disadvantages of scale formation. How these scales can be removed? So there are two methods we will adopt. One is mechanical method and the other one is chemical method. Mechanical method means with the help of wooden or wire brush, we have to scratch that thin layer, that is what we call as scale. That is, using a scraper, we have to scratch all the scales that are present on the inner side walls of the container. And the next one, it is thermal shock. That means we have to supply sudden maximum amount of temperature. After 1 or 2 minutes, we have to stop the supply of maximum temperature. That is sudden cooling. Sudden temperature supply and then sudden cooling. As a result, those cracks, or we can say those hairline, scales, they get cracked or they get exploded. So that is what we call as thermal shock. Using that method also, we can reduce the scales. And then the next thing, it is a mechanical one, that is called blow down operation. Just now we discussed about this blow down operation. And then coming to the next approach, that is chemical methods. So this is possible by adding some kind of chemicals to the water sample in the boiler. That is, either a diluted sulfuric acid we can add, or we can add EDTA. So these two are easily mixable, or we can say react with the salts that were present in the hard water, so that able to convert into insoluble precipitate, so that they can be removed by filtration. So coming to the removal techniques of scales, one is mechanical method. First approach is mechanical method and second approach is chemical method. Mechanical method includes using one scraper, that is a wooden or wire brush. We have to scratch all the inner side walls of boiler material, so that scales will be removed. And the second one, it is thermal shock. It is done by giving sudden maximum temperature and then sudden cooling, so that the entire scales will be blasted. And then next one is blow down operation. It is a mechanical method. We have to allow the passage of all that water by batches continuously, so that the entire scales, they will be removed and will collect at the bottom of the container, or we can say that blow down apparatus. So and then next thing is chemical method. So this is done by adding either dilute HCl or EDTA method. And what is the next boiler trouble that we are going to face when we use hard water is caustic embrittlement. Caustic embrittlement. So it is a kind of phenomena in which boiler material becomes too brittle. So boiler material will become too brittle. Brittle means easily broken. So that happens due to the accumulation of caustic substances, say for example Na2CO3. If sodium carbonate is present in more amount in dissolved state in water, then it is able to release NaOH. NaOH is a strong base. So in return, what it will do is, it is able to reduce the alkaline nature to the hot water sample that is taken in the boiler. So as a result, that boiler material, it is nothing but alloy of iron. So easily it combines with that NaOH. As a result, it becomes more brittle. That material becomes more brittle. So we will get a doubt, that is, why the presence of Na2CO3 will be there in the water. That means, whenever we are going to adopt some external treatment methods like lime soda process, lime and soda process, this Na2CO3 is used as a softener. It is meant for converting hard water into soft water. So calculated amounts as we go on adding, that is sodium carbonate to the water sample, then what it will do is, it is able to, on hydrolysis, it is able to release NaOH. That means, whenever this Na2CO3 is added to water sample in the boiler, immediately the formation of NaOH will take place. So NaOH is an example for strong base. So as a result, what will happen? Entire boiler water becomes more alkaline. So as already scales were present on the inner side walls of the boiler, as we are increasing the temperature, then there is a chance for hairline cracks. So what will happen, as hairline cracks were present on the inner side walls of the boiler, so that gaps will be there. Because of that capillary action, this NaOH comes in contact with the boiler material. As a result, it is able to form sodium ferroate. Sodium ferroate. So this is nothing but formation of caustic embrittlement of boiler material. So it will start from small parts like rivets, joints and bends. So what will happen, if external treatments like lime soda, it is adopted for reducing the hardness, in which we have to make use of Na2CO3, that is sodium carbonate, which is acting like a softener. So it is able to release NaOH into the water sample. So this produced NaOH, what it will do is, it is able to reach the boiler material through hairline cracks because of capillary action. As a result, it is able to react with the iron to form sodium ferrate as a result, and this is nothing but making brittleness to the boiler material. So caustic embrittlement will start from parts like joints, rivets and bends. So this obtained sodium ferrate, again it will not stay like that. So it is able to involve in decomposition to convert or to form magnetite, and it is able to regenerate NaOH. So NaOH is again regenerated due to the decomposition of sodium ferrate. So this is the mechanism that is happening. Let us see the reactions part. Let us go with the reactions part. So in this one, as I told you, Na2CO3 on adding to water, so it is able to release NaOH. This NaOH comes in contact with iron, that is Fe. So it is able to convert into sodium ferrate, NaFeO2. This sodium ferrate is able to decompose, NaFeO2 is able to decompose to form NaOH, that is 6 NaOH it is able to release. It will be like 3, okay, so which is highly concentrated. So this NaOH, here it is dilute NaOH and here it is concentrated NaOH. So because of this, alkaline nature gets increased. So this is the picture that is revealing caustic embrittlement. So because of this hairline cracks, here it is shown, because of this hairline cracks, that produced NaOH comes in contact with the material, that is iron. So as a result, it will become more brittle. So it involves in the breaking process. Yeah. So these are the reactions that I have discussed so far. Na2CO3 on adding to water, result will be NaOH formation, along with that CO2 will be released, and then that iron that is nothing but boiler material. So it is able to combine with this NaOH that was produced. As a result, the sodium ferrate will be the formation. The sodium ferrate again involves in decomposition with water molecules, that is in the water molecules. As a result, highly concentrated NaOH will be produced. Along with that, this is magnetite Fe3O4, that is anhydrous form of rusting of iron. So that means because of caustic embrittlement, consequence will be corrosion also. Boiler corrosion will take place. So this concept of caustic embrittlement we can explain using the approach of concentration cell concept. That means iron, that is boiler material, it is the metal we are going to consider, that is iron, which is under stress. That means which is in contact with the concentrated NaOH. That means here it is concentrated NaOH will act like anode, acting like anode, and the iron which is stress free. As I told you, rivets, bolts, joints, whatever be the thing, they will come under stressed parts. So exactly at that point, as that boiler material is in contact with concentrated NaOH, then it will act like anode area, and stress free regions, that is remaining portion of that boiler material with iron, will act like examples for cathode. So that's why same metals when immersed in same electrolytic solution of varying concentration, then we will call that cell as concentration cell. So here this one is an example for concept of concentration cell. As anode and cathode were separated, always at anode oxidation takes place, and at anode metal which is placed in anode position will involve in corrosion reaction. So this is about caustic embrittlement and how we can avoid or prevent this caustic embrittlement. Let us see the removal techniques. So coming to removal techniques part, by using sodium sulfate instead of sodium carbonate. As I told you, sodium carbonate is used as a softener in the lime soda process. We have to replace that one with sodium sulfate. Somehow we can reduce the formation of NaOH into the water, so that the alkaline nature will not be increased. So this is one control measure, and the other one is, if you block the hairline cracks that were present in the inner side walls of the boiler, that is making use of lignin or tannin or lignin. So generally we will hear this tannin, name of this tannin in what we can say leather processing units. That means whenever that hair follicles are removed from that leather during its processing, so it will have a kind of pores that were present because of that hair follicle presence. Gaps will be formed like pores. So if those were not blocked, that leather lifetime will be reduced. Insects and bugs will spoil that leather material. So for that, in leather processing units, they use it to they will make use of this tannin for blocking that hair follicles and all. So likewise, in boiler material also, for blocking that hairline cracks that were present on inner side walls of the container, we are going to make use of tannin or lignin. So using any one of these two can reduce the formation of caustic embrittlement. So in today's session, so far what we have discussed is, I started with boiler troubles. What happens if hard water it is used for steam generation. So in this we have two in our syllabus. First one is sludges and scales formation. Second one is caustic embrittlement. For each type, what are the reasons for its occurrence, what are the disadvantages or effects, and then control measures I explained in a detailed manner. So in the coming session, we are going to discuss or learn about internal treatment of hard water. That's all for today's class. Thank you so much. Have a nice day.